In chapter 8, we had two kinds of confidence intervals for unknown population mean. One was using the z, and the other one was using the t. So at the beginning, we plug the point estimate in both, and plus and minus the critical value, the z-score or the t-score. When we chose a z-score, we had a sigma and square root of n. When we use the t-score as a critical value, then we had a standard deviation, the sample standard deviation s, and here is a square root of n. Before, in chapter 9, we used the z as a test statistic, right? So now today, we are going to discuss is one mean t-test. Yep, here's the test statistic. It is not the z. Actually the z test statistic was x bar minus the mu 0 sigma over square root of n. So that is the same idea. Before, in chapter 8, we had a sigma, then we used a z. So here was a sigma, and we took the z as a test statistic. But now, we have a s here now. Then we are going to use the t-score as a test statistic. It's the same idea why we need the t-score as a critical value in chapter 8. Okay, so we can make the pair, the sigma with the z and s with the t. So here's the same idea. So the others is exactly same. The step number 1, we can state the null hypothesis and we can choose one of them. It depends on the claim. And in the textbook, the second step, we determine the significance level, and the next one is a test statistic. Now it will be the t-score, and before we got the p-value from the z-table. Here the z-test is actually, it was a z-test, but now we are going to get the critical value from the t-table. So today we are going to apply is another approach. It's a title is a critical value approach, and then make the decision and conclusion. It's the same way. So today we are going to apply the t-test with the t-test statistic. Then we are going to take the critical value from the t-table. So here's an example. So look at this. It is an example. So the step number 1, it is the same. The step number 1, we can state the null hypothesis and alternative hypothesis. It's always in the null is mu is equal to something. And we have 3 kinds of inequalities in alternative hypotheses. So when you read the example 9.16 is carefully, the claim was at 5% significance level. Do the data provide as a non-exceeding, right? And somewhere here, yep, it is a definition. It is a definition of the non-exceeded when pH is greater than 6, right? So we want to test if the lake non-exceeded. So non-exceeded when it's a pH is greater than 6. Is it greater than 6? And that one. So it will be is greater than is right tail. It's good, right? And the next one is the test statistic. Now we have a sample mean and S, right? So we are going to get the t-score, which was the x bar minus the mu 0 S over square root of n. So the sample mean 6.6 minus the mu 0, Yep, that is a mu 0. It's a 6. And S was given 0.672 over square root of, we finding is a 15 lakes. So the sample size is a 15. So let me take the difference, 6.6 minus 6, that is a positive 0.6 over 0.672 over square root of 15. So the test statistic, I have a 3.458. When we got the z-score, we need the 2 decimal places, okay? So yeah, so let me say it's 4.6. Okay, so it's the same thing. It's a 2 decimal places. And now, before with the z-score, we found a p-value, but now we are going to take the critical value. Critical value. It is a critical value approach. So let me go to the t-table. But before we go to the t-table, we have to know the alpha was 5% and the right tail. So now we can make the t distribution. You know, the t distribution looks like the standard normal distribution with the mean equal 0. And now we plug the alpha, the significance level, on the right tail. So here is a 0.05, the alpha, and the critical value, that is the value here. Okay, so there is a critical value. So we need the critical value from the t-table. To take the critical value, it's not only the alpha, and also we need the degree of freedom. How many degree of freedom? It's the same thing. It's n minus 1. Okay, so the sample size was 15. It's minus 1. That would be 14. So with the alpha and 14, now then let me go to the t-table. Yep, t-table here. I said we had right tail, that is a 1 tail probability. You know, here is a 2 tail, that is not equal to, but it's a greater than, less than, that is actually it's a 1 tail. And alpha is 0.05 for 1 tail. It was a right tail. And the degree of freedom was a 14. It's a 15 minus 1. Then here is a t-score, 1.761. That is the critical value, 1.761. So let me go up. I can say the critical value here is a 1.761. But now the test statistic was 3.46. You know, here the test statistic, the t-score was 3.46. Okay, so now I can say the area, I mean the right end, the right tail, that is the rejection reason. So now I can make the decision if the test statistic is bigger than the critical value, then reject the null hypothesis. It's another decision rule using the critical value. Okay, so please remember, as the other one, if the test statistic is bigger than the critical value, is bigger than its critical value, then we reject. Now it is true, so we reject the null hypothesis. It's actually sometimes the test statistics can be negative here, so generally, we can take the absolute value of the test statistic. But in this case, we had the positive test statistic, so we don't need the absolute value sign, but generally, yeah, we can take the absolute value of the test statistic is bigger than the critical value, then we are going to reject the null hypothesis. So now I rejected the null hypothesis, so I have to make the conclusion is based on the alternative hypothesis. It means it's bigger than 6. What does it mean? It's bigger than 6. It means it's non-exceeded. So let me make the conclusion. The lakes are, yes, it's a non-exceeded. Because we rejected the null hypothesis. So absolutely, when we take the p-value, then it's a right tail. It's greater than 3.46. That will be the p-value, but from the t-table, it is impossible to get exact p-value from the t-table. So instead of the p-value, we are going to take the critical value and compare to the test statistic to make the decision. Okay, here is another example. Let me try it. Now, step number 1, the null statement is mu is equal to, and alternative statement is mu. Let me see. Okay, the 20 people, the sample size, and that is the sample mean and the standard deviation from the sample. Here is the alpha, the significance level, and do the data provide sufficient evidence to differ from, it's not equal to, it's a two-tailed. Okay, in 2005, in 2005, the average is a 4.55. So we want to compare to the average in 2005, 4.55. And now we take the t-score, the sample mean minus the initial setting value in the null statement, and the sample standard deviation over square root of n. So the sample mean was 4.76 minus 4.55, and the sample standard deviation is a 2.30 over square root of the sample size was 20. So let me take the difference. 4.76 minus 4.55. Take the difference. It's a positive 0.21 over 2.30 over square root of 20. I have a test statistic as a 0.408. So that will be 0.41. Then now let me take the critical value. So let me make the t-table, the t distribution. It was the two-tailed. We don't need the t distribution. Let me go to the t-table directly, and alpha is at 10%. So let me go to the t-table. Just a second. How many degree of freedom? It's a 20 minus 119. Okay. So let me go to the t-table, and now we had the two-tail probability. The two-tail test is not equal to, and alpha is at 10%. So let me go to the same column. Before we had the right tail, it's one tail at 5%, but now it is a two-tail, it's a 10% in the same column, and the degree of freedom was at 19 from 20 minus 1. So the critical value is a 1.729. So let me go back. 1.729. So the critical value, I'm sorry, yep, the critical value is a 1.729. Okay, but the test statistic was here. It's not here, right? I said this one was the rejection reason. The rejection here, but the test statistic is less than the critical value. It's 0.41. So now, because the test statistic 0.41 is less than the critical value 1.729, so the decision will be not reject the null hypothesis. It's a fail to reject the null hypothesis. That means null statement is true. So what is the conclusion? It's a no difference. It's the same. Even you can make the conclusion does not change. It's the same. It's a no difference. Okay. So in this way, we can compare the test statistic and the critical value. And what was the decision rule? Yep, here is a decision rule. Yeah, please remember, if the absolute value of the test statistic is the bigger than the critical value, then reject the null hypothesis. Let me summarize here. Before the p-value approach, okay, the decision rule was if the p-value less than equal to the alpha. In this case, we compare the two probabilities. P-value and alpha, they are all probabilities. Then reject the null hypothesis. It is the decision rule in the z-test, right? But now we take the critical value from the t-table and compare to the test statistic. In general, it's absolute value of the test statistic, and bigger than equal to, then reject the null hypothesis. It's another the decision rule in the t-test. So be careful. The inequality, is less than equal to, but now it's bigger than equal to. Yeah, it's switched. So it was the z-test, and it is the t-test.